Alright, so here's a question we can definitely do without drawing a graph, but as soon as I see that it's a graph and we're given all the information to plot the graph on our calculators, I always go for it. So we see that. We're obviously going to make this f of x, and we're going to make this x here. So we are going to just pop that into our calculator and see what happens. It's about a cooling object. It's going to cool down, and those of you with a bit of knowledge about cooling things, it's going to cool down to a certain temperature, and that temperature will be room temperature. Alright, so let's have a little look. It's 22 plus 78 times by, in brackets, 0.85, and that's to the power of x. There we go. Now of course we can't see anything there because Control T, look, when the time is 0, the temperature of the soup is 100, okay, so it's boiling point basically of water, and then you can see as time increases, then the temperature reduces, and ultimately if you just keep scrolling down, you get a really good idea that the temperature is heading towards, there it is, 22 degrees C. So let's go ahead and change our window, Control T, toggle off, menu, window settings. Let's just go from -1, let's go up to maybe, I don't know, 100 minutes. The temperature here is -1, again up to, let's go 105, boom. Okay, that's what we expect to see. It's an exponential decay model, it's a cooling curve. It cools down to a temperature here of 22 degrees. You can also do a graph trace, menu, trace, graph trace. See that nice little line there? You can see the first number, 60, 70, 80 minutes and 22 degrees. Eventually it just runs out of 0.0000 and it's 22 degrees. So therefore let's go and have a look at our question now. So the first part A, state the temperature of the room suggested by the model. So you can see that it's 22 degrees C. You see that from the graph where the flat part is. B, find the temperature of the soup after 5 minutes. So when t equals 5, we want big T. Alright, so a number of ways. We can go straight to the formula. T equals 22, big T, plus 78 times 0.85 to the power of 5, right? And you just type that in as a normal calculation. But the good news is, as we've got the calculator already sorted out for us, we can do this in 2 ways with the calculator. We can do Control T, and we just scroll down to 5. Right, there's 5, and the temperature is 56.6. So we just type that in, 56.6 degrees C. Alright, we can also use the graph to Control G. We can type in 5 and we can find, oh my bad, it's not 5 is it? It's when t equals 5. Alright, so we can actually put in a vertical line, menu, graph entry, equation templates, and we can draw a line and we can draw a vertical line, and we can see, yeah, we get an idea of where this is, right? But I suppose that's the best way. Maybe one more, doc, insert a calculator page, because our function is saved as f1. We can just do f1 of 5, and out also comes 56.6 degrees. Alright, so there's quite a few different ways of doing that. And then there's a final part for the question, and the final part of the question wants to work backwards. If we have a certain time, if we have a certain temperature, how long does the soup take to reach that temperature? So this is kind of working backwards. So we've got a temperature of 30 degrees C, and we've got to find the little t. So this is 30 for big T equals 22 plus 78, 0.85, and that's to the t. Again, we've got a number of ways of solving this. I think people's favourite sometimes might be nsolve, menu, algebra and solve. Just type in the equation 30 equals 22 plus 78 open bracket times by 0.85. Make sure you get the power outside, and I'm going to put t. Then we have to comma t it. Right, and so we've got 14.0 mins. Another way, of course, is from the graph. We can literally go Control G, and we can, let's just see. So I've got the X function now. I'll go menu, graph entry function, and I'll put in a temperature of 30, and hopefully menu, analyze graph, intersection. We should see this graph with this graph, and we will get also the same 14 minutes.